Hello everyone, thank you for joining me today. Today I'm going to talk about an interesting topic from dashboard to defenses, building autonomous resilience at scale. I want to start with something we have all experienced. Imagine it's 2 in the morning. Your phone buzzes, you have just been paged. You pull yourself out of the bed, look at the dashboards, try to make sense of graphs and scramble to contain the problem. And in that moment, how many of you have thought, why can't the system just fix this itself? That's exactly the journey I want to share with you today. How we can move beyond watching problems and start building systems that defend themselves. In production environment, especially at scale, the 2 a.m. pager is not sustainable. Dashboards show problems, but they don't act. And while we have all seen heroic firefighting from engineers, this model simply doesn't scale when you are serving billions of requests. The mandate is clear. We must engineer reliability into the system itself, not leave it to the humans to keep everything alive. Let's start with observability. The old way was to collect everything, build endless dashboards, and hope someone noticed the right spike at the right time. But let's be honest, humans can't parse millions of data points in real time. The new way is SLO driven signals tied directly to user experience. We don't just measure CPU or memory, we measure whether user really succeeded. That means tracking P95 request latency, overall availability, and checkout success rate. We then set SLOs and we use error budget to decide when to release quickly and when to slow down. These turns reliability into something measurable and actionable. To make observability very useful, we use proven patterns. We use SLOs and error budgets as the release gatekeepers. We follow red, golden signals and use frameworks to ensure consistency across every service. Each service has a single golden dashboard, not dozens, so engineers know exactly where to look. We take an open telemetry first approach, so metrics, traces, and logs all flow through the standard pipeline. And we enrich metrics with trace IDs like that, so an engineer can jump directly from a latency spike to the trace that explains it. This makes observability more than just data. It makes it a foundation of automation. Metric traces and logs are only valuable if they are scale. For tracing, we propagate W3 trace context across every service. And we use tail-based sampling, so we always keep the interesting data, the errors and the outliers. For logs, we use structured JSON, we redact sensitive data at the collector, and we route logs by severity so we can look into what is necessary and don't log unnecessary noises. When these three pillars work together, you get correlated telemetry that you can trust. Observability also has to extend beyond the backend. We need change awareness. Every deployment, every feature flag toggle shows up as annotations on the dashboard. That way, when the latency jumps or error spikes, we can immediately see if it lines up with the new release. We need client visibility. Real user monitoring tells us about load times, layout shift, browser crashes, broken experiences. We also need edge visibility. CDN metrics show us cache hit ratio, and edge error rates, etc. And finally, we capacity and cost. We forecast saturation before it becomes an outage. And we take telemetry with the team and service ownership to make the cost visible. This way, we aren't just monitoring the backend, we are just monitoring the end-to-end experience and business impact. Dashboards alone are still reactive unless you add prediction. Static threshold always fails because what is normal is always changing. So we build capacity anomaly detectors that learn usage patterns and alert us before we hit hard limits. We then added AI models that forecast latency spikes and correlated logs, metrics, and traces to find out root cause faster. We also have models which detects error spikes based on capacity and incoming requests and predict the issues early. One of the most powerful innovation was using the browser JavaScript error as an anomaly signal. If a rollout suddenly increases JS error, the system automatically rolls back itself before user even noticed. That observability turning into proactive defense. Observability only matters if the alerts lead to an action. The old was an alert fires, a human wakes up, a human then looked into the dashboard and mitigate the issue. That is very slow. The new way is alerts are used as a control signals. So system identifies the issue and auto corrects. If a dependency slows, a circuit breaker trips immediately. If error budget burns too fast, a new deployment rolls back automatically. We use multi-burn rate alerts. Some of detect fast spikes and others detect slow leaks. And we only page humans when there is a real user impact. Everything else routes to a chat or tickets which will be handled offline. This keeps human focused on the problem that really matters, not everything, not noises. To build a trust, we use a tier strategy for automation. Tier 1 covers safe and reversible actions like throttles and circuit breakers. These always run automatically. Tier 2 covers progressive changes like shifting regional traffic. These can start automatically but allow for human oversight. Tier 3 covers complex or new incidents. The system notifies a human but also provides runbooks and context to accelerate the fix faster. This approach ensures that automation handles the easy 80% while human focus on the hard 20%. Our automation also relies on proven resilience patterns, multiple patterns described here. The circuit breaker pattern used to stop cascading failures. Bulkheads isolates failures so one service can't take down everything. Retry with exponential backoff ensures we don't overwhelm services that are recovered. Failover and load balancing strategies automatically route traffic around unhealthy regions. And cars and Saga patterns help us scale while maintaining consistency across distributed transactions. These patterns form our defense playbook. Delivery pipelines are not just about speed, they are about safety. Manual deployments get Manual deployment gates slow us down and add risk. Human misclicks, human approve without context. So we build fully automated pipelines. Every release goes through a canary deployment, progressive rollouts, and automatic rollback when new error spike happen or SLOs are breached. We shifted human review from pre-deployment approvals to post-deployment analysis when real system behavior is available. The result, faster velocity and safer production pipelines have become resilience engines. Another critical safeguard is dynamic rate limiting. Many of our incidents were not caused by infrastructure failure, but by workload anomalies. A buggy client spams requests. An internal batch of floods our APIs. Static limits always fails because they don't adopt. So we build adaptive throttling that learns normal traffic per client per endpoint, detects sudden deviations, and contain runway workloads automatically. This mechanism alone has prevented nearly 30% of our major incidents. Every safeguard we have today was born from scar tissue. A cascading outage gave us circuit breakers. A bad config rollout gave us progressive deployment. A runway client gave us adaptive throttling. So we made it cultural. Every postmortem asks two things. Could this have been auto-detected? Could it have been auto-mitigated? If the answer is yes, we build it. That's how you turn pain into progress, and engineers always toil. The hardest part of all this is trust. Engineers worry automation. Engineers worry automation might make things worse. So we build it progressively. In shadow mode, automation only logs what it have done. In suggest mode, it recommends action but waits for human approval. Only in autonomous mode, it does act independently, always within guardrails. Every action is transparent, reversible, and explainable. Over the time, engineers saw that the automation was actually more reliable than a tired human at 2 a.m. Trust won't be declared, it was earned. Resilience has to go beyond technical metrics. It might tie back to business outcomes. We run UI keep alive to continuously check front end flows. We track JavaScript errors in the browser as a front end anomaly signals. Most importantly, we watch business KPIs like cart abandonment and revenue impact, etc. If a release looks technically fine but causes abandonment to spike, the system rolled back automatically. Reliability isn't just keeping servers green, it is protecting both user and business. When you connect it all together, the blueprint is clear. Metrics become actionable signals. Alerts become closed loop mitigations. Deployments evolve into autonomous pipelines. Limits become adaptive safeguards. Firefighting turns into positive automation. And fear of automation becomes trust. That's how you evolve from the dashboard to defenses. So let me leave you with this. Reliability is not pager duty. Reliability is not dashboard. Reliability is autonomous resilience. Every incident is a chance to automate. Every scar is a chance to build defense. Step by step, you can build systems that don't just monitor themselves, but systems that defend themselves. Thank you.